Alright, so today I'm going to explain the frictional force. Now, the force friction, represented by F sub F, with this smaller f, meaning friction, is equal to force normal, which is represented by F sub n, with the n, meaning normal, times the coefficient of friction, which is represented by the Greek letter mu. Now, friction is a resistive force acting against forces applied to an object and an object's movement. So, if we have an object which is stationary relative to the surface it's resting on, and we apply a force to it, or force sub A being applied, then there will be a force of friction working against it. And this situation, when the object is stationary relative to the surface it's on, is known as static friction. Now there's another type of friction called kinetic friction. And this is when an object is moving relative to the force it's resting on. So it's moving with some velocity v. Now in this case, there's a force of friction working against the movement. Now, the force of the kinetic friction is less than the static friction. And this can be noticed by, say you try to move a really heavy box. Well, when you first try to move it, you have to apply a lot of force, and then you're working against static friction. However, when you get it moving, it's easier just to keep it moving. You don't have to apply as much force. Well, that is because of the kinetic friction, which is less than the static friction. Now, any energy that the frictional force takes away from an object, in the force of velocity, for example, is lost to heat, which becomes annoying when building machines because you lose a bunch of energy to heat due to friction. However, friction is very necessary because it allows us to grip objects and to build infrastructure and to just generally exist. So it can be annoying, but it's necessary for survival. Now, in the equation I mentioned for the frictional force, there were a couple things that you may not necessarily be familiar with. Among those, the normal force. Now, the normal force is a force applied by a surface that is directly perpendicular to the surface on objects resting on that surface. And this is used to stop the objects from falling through that surface. So, for example, let's say we have this table with a bowl resting on it. Now, the gravitational force pulls that bowl downward, and the gravitational force is represented by F sub g, g being gravity. So the gravitational force pulls downward on that bowl and wants to bring that bowl down. However, there's a table in the way, so the force normal counteracts that table. It directly counteracts the force of gravity and keeps the bowl where it is. Now, I mentioned that the force normal is always perpendicular to the surface. So, say we have a slant with angle theta. In this case, the force of normal is off to the side because it's perpendicular to the surface. So it's not straight upwards, it's off to the side. Now, the force of normal is most often used to counteract gravity. However, in this situation, it can't counteract all of gravity. However, it counteracts some of it. And to figure out how much of the gravity that the force of normal counteracts, we're going to split up the gravitational force up into components. There is one that is anti-parallel. Anti-parallel means that the force is in the exact opposite of the other direction. And one that is perpendicular to the normal force. Now, due to geometry, this angle here is also theta. And you can work that out for yourself as well, if you want to. Now, we typically call this component here y, and this component here x. Now, the normal force is able to cancel out y. So the normal force is exactly equal to this component of the gravitational force. So F sub n equals the cosine of theta times the gravitational force. It's the cosine because cosine is adjacent over hypotenuse, and hypotenuse is the full gravitational force, so that gives us the y component. So that's the normal force. Now, what about the x component of the frictional force, of the gravitational force? right in a way, that's counteracted by the frictional force. Force of friction counteracts that component. Now, the force of friction, unlike the force normal, may not be enough to counteract the x component. The force of friction is equal to the coefficient of friction, mu, times the cosine of theta times force g. Notice that this section here is the normal force, because, mu times force normal. Now, assuming that mu is big enough and that the theta is small enough, the force of friction may be able to counteract the x component of the gravitational force, but not necessarily. And if the force of friction is not able to counteract the x component of the gravitational force, the object will start sliding this way. However, if it is able to counteract it, the object will stay where it is. But this is the normal force. It's perpendicular to its surface. Now, I have one last thing to explain. The coefficient of friction. Now, the coefficient of friction is a valueless constant that exists between two objects. And I believe it is different between each object. So each pair of objects you get will have a different coefficient of friction. Now, the coefficient of friction is obtained experimentally. As far as I know, you cannot take any properties of the objects and calculate the coefficient of friction using some mathematics formula. Now, the way you calculate coefficient of friction is you take an object, and resting on the surface, and you apply a force to it. Now, what you do is you measure that object's acceleration, multiply it by that object's mass, subtract the force you applied to it, and that will equal your frictional force. Now, similarly, you multiply that object's mass by its gravity, and this will be equal to the normal force, as I explained earlier. Now what you do is you divide the force of friction by the normal force, and this should give you your coefficient of friction. So you obtain it experimentally, not through any real mathematics. I mean, this formula is mathematics, but it's experimentally at its base. Now, there are actually two different coefficients of frictions between objects. The kinetic friction, or mu sub k, k being kinetic, and the static friction, mu sub s, s for static. Now, in case you're curious, I'm going to explain why kinetic friction is less than static friction. And this gets at the basis of how friction exists. Now, on any object, there will be minor impurities on it. There will be ridges. Now, it may be a very smooth object, it looks smooth and even feels smooth, but if you zoom in far enough, the object will have little bumps to it. Now, this exists on all objects. So say we have bumps on the surface, and we also have bumps on the object. Now, this is what causes friction, these two bumps passing over each other. So we have a force applied here. Well, these bumps act against the object. The surface bumps act against the object bumps and try to stop the force applied. It's essentially like a bunch of small normal forces just acting perpendicular to it. But so it tries to stop the object from moving. Now, the reason static friction is more is because on a stationary object, the object has had time to settle into the surface bumps. So they're settled right there. So it takes a bunch of more force to get the object out of those bumps, because you have to get it up and then go over. However, in a moving object, the bumps don't necessarily have time to settle. They're kind of just skipping over the surface bumps. So it requires less force to, just get them over the little bit of bumps. So it's because the object is essentially just skipping over the gaps, and it's not allowed to settle, which is why kinetic friction is less than static friction. But yeah, so that is the force of friction. Hope you enjoyed it, hope you learned something, and see ya!